Hello everyone, happy to see you here, welcome back to my channel. Today we have a very interesting question. We know that the product a times b equal to 20 and a sum a plus b equal to 4, and we need to find our a and b. If you have your solution, your answer, you can also write your solution down into the comment section and then we will check our answers. So first of all, from this second equation, let's express our b. So b will be equal to 4 minus a. This is our first step. Let's do this right now. So as a result, we have b equal to 4 minus a. This is our first step, and right now let's plug in, instead of this b, let's plug in 4 minus a. This is equal sign, so we can easily change this b by 4 minus a, and then let's plug in this into first equation. Let's do this right now. As a result, we have a times 4 minus a, and equal to 20. So we plug in this thing into first equation. Right now let's simplify this. We have only our one variable, we have only our a, so we can easily find it real quick. Let's do this right now. So as a result, we have 4a minus we have a square equal to 20. Okay, this is a quadratic equation. So right now we prefer 0 on the right side. So right now let's subtract 20 from both sides. As a result, we have 4a minus a square and minus 20 equal to 0. And the second thing we're going to do, we're going to change in order a little bit, because we prefer the second power on the first position, a on the second, and constant on the third. We have constant on the third position, but we need to change these variables places. So we have minus a square plus 4a and minus 20 equal to 0. And right now the final tricky move, and we need to multiply both sides by minus 1, because we don't need this minus right here. We prefer a classic quadratic equation, so a, b, and c, so without a minus right here. So it simplifies us a lot. So as a result, we have a square minus 4a and plus 20 equal to 0. Yeah, we have a final quadratic equation. So right now let's solve it. First of all, I'm going to use our classic method with the coefficients. So we have a equal to 1, yeah, b equal to minus 4, and c equal to 20. So this is a basic method, and right now I'm going to find real quick discriminant, and I'm going to plug in a discriminant into our formula. So we have minus b plus minus square root of d. You know this formula, yeah? So first of all, let's find our discriminant real quick. Discriminant equal to b square minus 4ac. Okay, let's plug in it. So we have minus b, so we have not like minus, we have b equal to minus 4, so we have minus 4 square minus 4 times 1 and times 20. Let's simplify this real quick. As a result, we have minus 4 square equal to 16 minus 4 times 20 equal to 80. And as you can see, we have a negative discriminant with the negative sign. We have minus 64. Doesn't matter, let's find our a first and a second. Everyone need to know this formula. So we have a first and second equal to, we have minus b plus minus square root of discriminant and all over to a equal to minus b. So we have minus b equal to minus 4, yeah, minus b, plus minus square root of discriminant, square root of minus 64, yeah, minus 64, and we divide all of the thing by 2a, 2 times 1. Right now let's simplify this real quick. Minus is plus, so as a result we have 4 plus minus this square root of minus 64. We can easily simplify this. We can write it as a product minus 1 times 64. Okay, we can write it like that, and we divide it by 2. Right now we can easily split it, because there's like a great property in terms of like multiplication, so a great rule. So when we have square root of a times b, we can write it as square root of a times square root of b. So we can easily split this square root. And we have 4 plus minus square root of minus 1 times square root of 64, and we divide it by 2. Right now, square root of minus 1 equal to I. These are a complex unit. We can't find it in terms of like real numbers, because we have a negative, and square inside this expression inside this square root need to be positive. We have a negative, so right now we're going to consider it as a complex root. So we have 4 plus minus square root of minus 1 equal to I, and square root of 64 equal to 8. Everyone know about it. So I times 8, we can write it as 8I, but right now we're going to do division by 2. So as a result, we have 4 over 2 plus minus 8i over 2. So we can divide it by parts, by our denominator. We can easily do this. If you want to go back, you can easily You can easily do this because we have the same denominator. We can easily consider this expression. Okay, so everything is great. Equal to, right now 4 over 2 equal to 2. Right here we have plus minus 4i, plus minus 4i, and these are our two roots. So right now let's write our a first and second, but we can easily do this with the a first without a first and second. We can easily right now find our exact value of a first equal to, let's try with the positive sign, so 2 plus 4i, and of course a second equal to 2 minus 4i. So these are our two roots, and don't forget about our b, because we need to find. So let's write right here. So I'm gonna write on the left side. Let's do this. So but b equal to 4 minus a. So right now let's find our b first. So b first will be equal to 4 minus a first. Okay, this is our a first, so b first is equal to 4 minus a first equal to 2 plus 4i, and right here we have our parentheses, so we can do this like b first equal to 4 minus 2 minus 4i. We can easily subtract 4 minus 2, and our b first gonna be equal to 2 minus 4i. It looks like the same thing, but with a different sign. So we have 2 plus 4i and 2 minus 4i. And I hope you see that our b second will be equal to the with the same principle, you know, with the looks like 2 plus 4i, but let's check it real quick. Everything can happen. So b second equal to 4 minus a second. And we have b second equal to 4 minus 2 minus 4i. And as a result, we have b second equal to 4 minus 2 and plus 4i. As a result, our b second equal to, right here we have 2, so 2 plus 4i. Yeah, yes, you can see the same principle. So it looks like we solved this question, but we can easily check our roots, because in the beginning we had ab equal to 20, a plus b equal to 4. So right now let's write our final answer to this question and then check it real quick. So we have a and b, our two pairs, equal to, we have the first pair, we have 2 plus 4i and 2 minus 4i. This is our first pair solution, and we have the second pair, 2 minus 4i and 2 plus 4i. So these are our two pairs of solution. These are our complex roots. So you don't have real number roots. These are our complex roots, but let's check it. Let's check it real quick. First of all, in the beginning, we had that our a plus b equal to 4 and ab equal to 20. Let's start, for example, with addition. And here's like the great trick for us, because we don't need to check both of these roots, because we have addition. So doesn't matter, you can easily have 2 plus 2, not like 2 plus 2, let's try with the 2 plus 5, and 2 plus 5 equal to 5 plus 2, so you can easily change position right here, and you will have the same thing. It works only with addition and multiplication, and this is exactly our case, so you don't need to check both of these, because with 100% probability we're gonna add it. So as a result, we have absolutely the same thing. So let's check, for example, this first pair. So as a result, we have 2 plus 4i plus 2 minus 4i. As a result, we can easily cancel this 4i, and as a result, we have 4, and we need this 4 right here. So addition works absolutely perfectly. Let's check real quick our multiplication. In terms of multiplication, we're gonna have like 2 plus 4i, the first root, and we have 2 times 2 minus 4i, and a lot of people try to multiply it, but as you can see right here, we have our school identity. If you know a little bit about algebra, we have a formula a square minus b square. It is equal to a plus b times a minus b. And if you look right here, we have absolutely the same thing. These are a, this is our a, this is our b, this is our b, so we can consider it as difference of squares. This is our school identity. So right here we can write it as 2 square minus 4i square. Okay, 4i raised to the second power equal to 20. And of course right here we have 4, 2 square minus, we have 16 times I square. So we need to raise both of these elements to the second power equal to 20, I square equal to minus 1. Yeah, so as a result we have 4 plus 16 equal to 20. So everything works absolutely perfectly. So as you can see, this is our quick proof. I'm gonna write it right here. This is our quick proof to our question. And of course, I don't have enough space right here. And of course, I have this line. I already written this line at this place, so I don't want to rewrite it because this is our answer. Okay, this is our quick answer to this question. So two pairs of solution, the first pair of solution and the second one. So this is my explanation to this question. I really hope you enjoyed. If you do, you can easily write your response into the comment section. Let's discuss a little bit about this question. To be honest, this is not a hard question, but I think maybe a lot of students watch my channel, and this is like a quick, relaxing question for everyone. Maybe someone doesn't know how can we solve this type of question. This is a basic system of equation from school. We express something from the second on the first equation, and we're gonna plug in it to the second one. This is like the most popular method, and with this method we solve this with the basic steps: quadratic equation, two pairs. So I really think you enjoy it. So thank you for your time. Wish you all the best in your life. Take care of yourself, and of course write your notes, write your response down into the comment section. Let's exchange information. It will be really interesting to read about it. Wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.